Okay, hello everyone. This is a video just about how to solve logarithmic equations, really, or the kinds of equations where we might use logarithms to solve them. Now, before I start this, I'd like to go through the log laws because whenever you're solving any log equation, log laws are absolutely crucial and critical to actually getting the right answer. So, yeah, let's have a look at some of the log laws. Now, what do we know? Well, before we start on the log laws, let's just talk about what a logarithm actually is. This is what I call the unwritten log law as well. It's a really handy thing to bear in mind. How do logs work? Well, logs work essentially to find powers. Let's just write that down. Logs find powers. Yeah, that's what they do. Now, what does that even mean? Well, it means, for example, that 3 to the power of 4, if you do 3 times 3 times 3 times 3, you get to 81. Yeah? Now, I just remember that. I'm just aware that 3 to the power of 4 is 81. Now, that kind of helps me remember how logs work because the way we would frame that kind of fact using logarithms is like this. Log base 3 of 81 equals 4. Now, if I remember this crucial fact, it shows me how I can undo a logarithm. Because if I've ever got a statement of fact like this, all I need to remember is it's the little number over here to the power of the number which it equals should equal the bigger number within the logarithm here. Yeah, that is the way logs work. They say basically when you see log base 3 of 81, it's saying what do you need to put 3 to the power of to get to 81? Because logs find powers. That's what they do. They find what you need to put that to the power of to get to that. Okay, so I hope that makes it clear how logarithms work. So just a few examples of that. You could do something like, I don't know, log base 2 of 32. Okay, what does that mean? It means what do I need to put 2 to the power of to get to 32? The answer is 5, and it's because 2 to the power of 5 is 32. Or log base 3 of 1/9. Ooh, what do we need to put 3 to the power of to get to 1/9? Well, it's actually minus 2, because 3 to the power of negative 2 would give you 1/9. You can even do things like this, log base x of 1 over root x. Okay, that's a little bit more harder to consider, but x needs to be put to the power of negative a half if you want it to become 1 over root x. And that's why when you're thinking about logarithms, it's crucial and critical that you understand how indices work, yeah? Because obviously what I've done there, a lot of those answers are dependent upon me understanding inside out how indices work and things like 3 to the power of minus 2 is 1/9, etc., etc., etc. So that's what logs actually do. Now, let's do some laws. Let's write down some laws worth remembering. I'm not going to prove them today, but I promise you they are easy to prove. uh, log A plus log b. Now notice I'm not writing the little number down here and here. If the number isn't written down, then you can take it as the base being 10, but it actually does work for any base where it's the same, and this must be the same base. So maybe I should put a little x in here and an x in here. Well, if you've ever got that, that's the same as log base x of ab. You can just times them together. You've got the sort of like mirror one of that where you're subtracting. Well, that's log base x of a over b. And then you've got the last one, which is like the flicking the power down one. Log base x of a to the power of n. I think this is a direct consequence of this one. If you had like a squared here, well, that would be log a plus log a, yeah, which is 2 log a. So 2 log a is the same as log a squared. So the power kind of flicks down. And n log a is the same as log a to the power of m. Yeah. Uh, so yeah, there we go. I finished it. Sorry, messed up. Okay, so those are the 3 log laws which I always bear in mind, as well as the unwritten log law of how you undo a logarithm. That's showing me really how I undo a logarithm. So if I've got that statement, I can just say that to the power of that is that. So there's really 4 laws, 4 critical laws, I would say, that you need to remember. And I'll show you in these questions that I'm about to do, I'll be using all of them at some point or another. So let's take a few questions. Let's take solve, and I'm only going to be doing solving. I'm not going to be doing sketching in this video. I'm going to be doing that in another video. Let's solve 2 log base 6 of x equals log base 6 of 2x minus 5 plus log base 6 of 5. Yeah. Now, when I see a question like this, the first thing I'm happy about is that the bases are the same throughout, which means the log laws which I just showed you, I can apply almost without thinking. So what I'm going to do first is I'm going to get rid of this 2 because I don't like 2's or 3's in front of my logs. I like to put them up as the powers. So I'm going to make that log base 6 of x squared. And my strategy here for solving this is essentially marry up the logarithms, yeah? Now, straight away I can marry 2 on this side, can't I? Because I could do 5 times 2x minus 5. So let's actually do that. Because, you know, why not do as much as we can? So I've put that up as a power, and then on the right hand side I'm going to make that 5 times 2x minus 5. Now what I could do at this stage, if you've ever got like log base 6 of stuff equals log base 6 of other stuff, you can essentially just ignore the log base 6's. What you're essentially doing is exponentiating both sides, doing 6 to the power of both sides. But you can just ignore the logarithms and think of it like that. So what we can just do now is just say, okay, x squared equals 5 times 2x is 10x, and 5 times minus 5 is minus 25. And now we're in a really strong position. We can just take these over and factorize the quadratic. It's always, so much in A level ends up being a quadratic. X minus 5, x minus 5. So x equals 5 looks to be the only solution. Do put it back in up here and if you're allowed a calculator, check that it works on your calculator in the original equation. Any equation which you solve in maths, you should be able to check. And sure enough, we can check that if we plug it back in, plug it into a calculator. Okay, so that's the first one. That's a fairly straightforward one. Let's try another one now. Let's get them progressively more and more slightly tricky. Let's do log base 7 of 4x equals log base 7. I've pinched these, by the way, from the Solomon questions. 1 over x minus 6 plus 1. Yeah. Now, I guess what stresses me out with a question like this is the plus 1. You could, there's various ways of handling it as well. You could, if you like, immediately write this as log base 7 of 7. Yeah, because that equals 1. 7 to the power of 1 equals 7. That's one way. It's not the way I'm going to use, but it's a perfectly valid way of approaching this. If you like that kind of way, be my guest and approach it like that. What I'm going to do is, and there's lots of kind of ways of thinking about it correctly, but there's also some invalid approaches. Be careful. This is the same as x minus 6 to the minus 1. I'm going to bring that minus 1 down in front of it like that to make it log minus log base 7 of x minus 6. And then I'm just going to add this over here. So I get log base 7 of 4x plus log base 7 of x minus 6 equals 1. And then I'm going to use the log law where I times them together. So log base 7 of 4x squared minus 24x, if you like, in brackets, equals 1. Okay, when I see something like this, this is where I get a chance to use my, as I describe it, unwritten log law. That to the power of that equals that. It's the way you undo logs. I often write in the margin, log base 3 of 81 is 4, and it's because 3 to the power of 4 is 81. So you can mimic the process. Do that to the power of that is that to undo the logarithm. That to the power of that is that to undo the logarithm. So you get 4x squared minus 24x equals 7 to the power of 1, which is obviously just 7. You then get 4x squared minus 24x minus 7 is 0. Bit disappointed here really in this question because actually it doesn't factorize, so I had to use my calculator. Well, I didn't have to use my calculator, but I did use my calculator. I was feeling pretty lazy. And you get from that quadratic 3 plus or minus a half root 43. Now, with any of your solutions in logarithms, it's actually really important that you plug values back in to make sure you're not doing log of a negative number. Yeah, let's say log base 10 of like minus 5 or something like that. That is no good. Yeah, and the reason is for various really awkward reasons about what it would do to the function, we only allow positive values we're only allowed to take take logarithms of positive values. Think of the log graph. Think of the log graph. You know, look at the log graph, and the log graph, and I'm doing this in another video actually, the log graph, but it looks something like this. You're not allowed to take logarithms of negative values. Yeah, it's because it doesn't really make much sense, particularly if you've got something like this: log base 2 of minus 4. Yeah, what do you need to put 2 to the power of to get negative 4? Well, it's impossible. You can't put 2 to the power of anything to get negative 4. And so we don't allow negative numbers in there. Now, if we look at my answer, I've got 3 plus or minus a half root 43. Now, 3 minus a half root 43 is actually negative. And so if you plug it back in here at the start, that is not going to be allowed. It's going to give you log of a negative number. And so what you must do at the end is exclude the value which you're not allowed here. So I'm just going to say exclude 3 minus a half root 43. So just x equals 3 plus a half root 43. And it's done. Yeah, and like I say, I just used the solving the quadratic function on my calculator to work out that 3 plus or minus a half root 43. I was feeling pretty lazy. Okay, let's try another one. Let's try another one. Let's try a, ooh, yeah, let's try this one. Let's say you were asked to solve log base 2 of y equals log base 2 of 3 minus 2x plus 1. And log base 4 of x equals log base 4. Oh, sorry. That's actually, that's not the question. Once again, I'm just borrowing these questions straight from, well, I'm taking them from the Solomon exercise. And this is an example of simultaneous equations. We've got two unknowns to find this time, x and y, and two equations. And there's some logs in there. Now, does that make this massively harder than normal solving simultaneous equations? Not really. Just use the log laws first. Yeah, you've got two equations, sometimes helpful to call them A and B. Yeah, working with A, let's get rid of the logarithms because nobody understands logarithms, do they? Well, of course we do, but yeah, let's get rid of them because it's harder, you know, with them still lingering in there. So I'm going to pull this log over to that side and have this as log base 2 of y minus log base 2 of 3 minus 2x equals 1. And yes, I can immediately rewrite that as log base 2 of y over 3 minus 2x equals 1. And now I can use my unwritten log law to do 2 to the power of 1 equals this. So I get y over 3 minus 2x equals 2 to the power of 1, which is just 2. Yeah. Now that's great because for A, I've managed to write the whole thing without logarithms. I'm going to do exactly the same kind of trick for B. Yeah, I want to get rid of the logarithms. Look, they've even got different bases. I definitely want to get rid of them. Okay, first log law I can use, I'm sure you'll see it straight away, is one where you times them together. Then I can use the unwritten log law as I describe it. That to the power of that is that. So xy equals 4 to the power of a half. Well, let's just write that as xy equals 2, because to the power of a half means square root. Okay, and we've got this set up. What we're going to do next? Well, now we can just solve this as if it was a GCSE question. Personally, I'd probably do this. Y is 2 times 3 minus 2x, which is 6 minus 4x, and then I just plug it in here. So I've got x times 6 minus 4x equals 2. So 6x minus 4x squared equals 2. That rearranges into what we got here. I'm going to halve everything and I'm going to move all that on that side. So I'm going to get 2x squared minus 3x plus 1. And then I'm going to factorize 2x minus 1, x minus 1. And so x is a half, or x equals 1. Don't forget to find the y's. It's a simultaneous equation. We need the other ones. If x is a half, y's got to be 4. And if x is 1, y's got to be 2. And you've done it. Don't forget, we really should plug things back in here to make sure we're not taking logs of negative numbers. But I think with all those values, you're going to be absolutely fine you're going to find that you're not taking logs of negative numbers anywhere. The 3 minus 2x might be a bit risky, but even when you're using x is 1, you haven't gone negative, so you're good. Okay, so that is yeah, a simultaneous equations question. Let's try one more question. Let's try, oh no, oh yeah, I haven't done that one yet. I haven't done, let's try one which looks a bit different. It's another solving equation one though. This is one which isn't really massively about logs till the very end, but it is one I'm sure you'll want me to go through. 3 to the 2x plus 1 plus 15 equals 2 times 3 to the x plus 2. Now, what makes this question hard? Well, I suppose it is knowing what to do. It is through bitter experience that I can look at this and say straight away, this is a quadratic in disguise. Yeah, this is a quadratic in disguise, and you'll get used to recognizing quadratics in disguise. Why is it quadratic in disguise? Well, play with the powers, and you'll see this is really 3 to the 2x times 3 to the power of 1, because we would add the powers there to get that. Ignore the plus 15 for the moment. And this is really 2 times 3 to the x times 3 squared, yeah? Because you would add the powers. Well, that's the same as 3 times 3 to the 2x plus 15 equals 18 times 3 to the x. Now it becomes a bit more obvious that this is a quadratic in disguise. It becomes especially obvious if you let u equal 3 to the x, or pick a letter. Because then u squared would be 3 to the 2x. Well, it would be 3 to the x all squared, which is 3 to the 2x, because you multiply the powers in that situation. And so why have we got a quadratic here? Because we've got 3u squared plus 15 equals 18u. Divide everything by 3. You've got u squared plus 5 equals 6u. And so now we can just factorize as normal and solve. U squared minus 6u plus 5 equals 0. So u minus 1, u minus 6, oh, u minus 5 equals 0. Don't forget u is 3 to the x. So, and we want the x values. 3 to the x equals 1, or 3 to the x equals 5. And so sure enough, we get x equals 0, because 3 to the 0 is 1, or x equals, well, this is a log problem. It's basically log base 3 of 5, yeah? We're saying, what do we need to put 3 to the power of to get to 5? And you can, because your calculators deal with mixed bases now, that's fine. And I think that comes to 1.46. Okay, thank you for listening. I hope that's helped you a little bit with logarithms, and good luck with the revision. Hope it goes really well, and don't forget you can get in touch with me via email if you want any little Zoom sessions or anything like that to clear up any misconceptions. Let me know. Okay, keep up the hard work, and bye-bye.